Hello students, as we already discussed in the previous video, Signals and System, I'm Jagan Babu, Assistant Professor, RMD Engineering College, Department of ECE. We are in the topic classifications of signals and system under the sketch of the plot in the unit number 1 in signals and system subject for EC department. We will see the one more problem in unit number 1 which is also very important. What we discussed previously is signal, now we are going to discuss about the systems. The problem is y of n is equal to sine into x of n. Find linear and non-linear, time variant and invariant, causal non-causal, static dynamic, stable and stable. Okay, we'll move to the first case, linear non-linear. First one is linear non-linear. Okay, take the question. Y of n is equal to sine x of n. Step number 1, whatever the question is given, write in term of 1, 2 and 3, both input and outputs, x of n as well as the y of n. So first step, y1 of n is equal to sine x1 of n, y2 of n is equal to sine x2 of n, y3 of n is equal to sine x3 of n. Equation number 1, 2 and 3. Next, step 2, by using superposition theorem. So whenever linear case defaults, it will be obeys the superposition theorem. You know what is called superposition theorem. When two or more charges, when two or more points are connected, that point is calculated by the net force or net points. That is called a superposition theorem. Where I am taking the expression, the LHS is x3 of n, which is equal to, actually a formula to be written, a1 x1 of n plus b x2 of n is equal to a y1 of n plus b y2 of n. So I am taking the LHS part, x3 of n is equal to a x1 of n plus b x2 of n. Substitute the equation. Substitute the equation. Therefore, y3 of n is equal to sine a x1 of n plus b x2 of n. y3 of n is equal to multiply sine of a x1 of n plus b sine into x2 of n. Equation number A. Now come to the next step. Take the next RHS part. I am taking a consider as a y3 dash of n. So y3 dash of n is equal to a y1 of n plus b y2 of n. Take this and substitute the equation number 1 and 2. In equation number 1, what is equation number 1? y3 dash of n is equal to a into sine x1 of n plus b into sine x2 of n. So I am substituting here a value as it is, keeping here instead of y1 of n I substitute as sine x1 of n plus b I am keeping as it is instead of y2 of n sine x2 of n, which is equal to, next step, multiply the a and b inside. Therefore, a sine x1 of n plus b sine x2 of n. Equation number B. Now check in step number 2, equation A. In step number 3, equation B. Both are same. y3 of n is equal to y3 dash of n. If it satisfies y3 of n is equal to y3 dash of n, hence linearity is proved. The given system is said to be linear. Okay. Come to the second case. Time variant or time invariant. We have only two steps in the time variant and invariant. Take the question, y of n equal to sine into x of n. Step number 1, output delayed by input with k second. Output delayed by input with k second. That means any function, sine of, cos of, x of, whatever it may be, inside the bracket n it was delayed. It to be delayed, it will be delayed. Take into any condition. Okay, so check here, y of n comma k. Why I taken k? Because I am going to delay the sample as k value. Since it is a discrete, you have to use k. Since if it is in a continuous, you have to use capital T. So y of n comma k is equal to sine x of n. It should be delayed, right? You should mention as n minus k. Equation number 1. You have to represent as minus k. Step 2. Output delayed by input with n minus k second. Now the total sample will be delayed. Previous case, the sample was delayed with the particular sample to the next value. Now the total sample is going to delay now. So now y of n minus k is equal to sine x of n to be totally replaced by n minus k. Equation number 2. Now check both the equations are same, the sine function. The first function was delayed, second function also will delayed by n minus k. So both are equal if it is time invariant. If both are not equal, if it is time variant. Now both are equal, sine of x of n minus k, sine of x minus k. So both are same. The property belongs to time invariant. Next case, causal and non-causal. Okay, take any cases, one delayed sample, one future sample, one present sample. Okay, past, present and future. So I'm taking the value of minus 1, 0, 1. So my present value is 0. My past value is minus 1. My future value will be plus 1. When I put n is equal to minus 1, so sine x of minus 1. When I put n equal to 0, sine x of 0. When I put n equal to 1, sine x of 1. All will be varying with respect to the present values, minus 1, 0, 0, 1, 1. So all are depends only on the present values. Hence the given system is called as causal system because it depends on the present values. Present and past indicates causal, future will indicate the non-causal system. Next, static and dynamic. The same thing we are following in the causal, but static is follow only the present values. Past and future will depends on the dynamic because the dynamic it represents, it will be changes. When changes will occur, either in the future or either in the past. So the given system will be static. Stable and unstable. We have the BIBO condition, which is called as bounded input, bounded output condition. The formula will be h of k. Summation k equal to minus infinity, modulus of h of k less than infinity. If you take the x of n value to be substituted from 0 to infinity, it will be definitely vary with the function. So the given system satisfies the BIBO condition. The given system is said to be stable. Hope you clear with the classification of system with the 5 types: linear, non-linear, variant, invariant, causal, non-causal, stable, unstable, static and dynamic. Thank you guys.